Hi, welcome to the Cool Data Project Show. I am Kristen Kerr, a developer advocate for Comet, where with one function, you can make your training runs reproducible. And this is the Cool Data Project Show, where I interview practitioners in ML, DL, and AI about cool projects that they're working on. And today I'm here with Peter, and he works on so much cool stuff that I've had him here twice. He's the first person to be on the Cool Data Project Show a second time, and today he's going to be telling us about 3D pose estimation. And I'm wearing my Roboflow shirt, but Peter, would you like to introduce yourself again and tell us a bit about Roboflow?
First of all, I'm kind of like honored. I didn't know that I'm the first person who is multiple times in the show. That's great. Yes, I'm Peter. Based in Poland, work for Roboflow as as a ML growth engineer, which is very weird name for the position, but you can think about it as a developer advocate. So my role in Roboflow is to make the Roboflow visible by doing things not necessarily relatable to Roboflow directly, like building cool projects. That one is actually from my private repository of projects, but I will mention one of the projects from Roboflow that we also where we also kind of like touched on the computer vision in sports. So yeah, that would be it.
All right, awesome. And so I don't want to steal your thunder, but because you have a whole presentation put together, but before we get into it, do you want to tell us a little bit about how you got the data?
Yeah, so for those people who know what we will be doing, you most likely saw a visualization. Those who are not, we will basically replicate the movement of person who is juggling the football or soccer ball in 3D, and the recording itself was done by myself and my friend who is actually on the recording. So we actually went to a physical location and recorded him juggling the ball with two cameras, and that's how we started the whole project.
All right, awesome. Actually, I think we should probably just get straight in because I assume that you are going
it would be much easier to explain people what we are doing when they see the visualization, that's for sure.
Yeah, nice glasses.
I added that like 10 minutes before we started, so I was like, okay, let's make it a bit more less serious and more fun. So that's what I aimed for. Cool. So shall I start?
Yeah,
the mic is mine. Okay. Cool. So like we said at the very beginning, and by the way, Kristen, if there will be any questions, just let me know because I'm not looking at the chat, so I have no clue.
I've got it.
Okay, so we will be talking about 3D pose estimation in sports with a specific focus on football or soccer, depends on where you live. And the project that I will be talking about is what you see right now on the screen. We basically tried our best to model the movement of the player. And what is also important, we didn't stop at pose estimation. We also basically strived to show how it interacts with the physical object. Yeah. So we have a player, but we also have a ball, and we show the interaction between those two. And I will obviously cover a little bit in detail how did we do that, because that's not very straightforward when we talk about the specific models, because you need more than one model to do that. The whole project was motivated by something that happened a few months ago. So by FIFA World Cup that was based in Qatar, and during that World Cup they had this new technology I mean, like, technology is not necessarily super new, but it was done differently before, and now it's done using computer vision, actually. So I was watching the game, and during the game, you didn't see all those like stickmans with coordinates. All you see is the visualization, computer visualization that was showing. So the second part of that visualization, where you actually see a player. And you know exactly what is the location of that player on the football pitch and what is the relative location of other players with that player. And that's pretty important because in football there is a rule that the player from the offensive team, the closest player from the offensive team, cannot be closer to the goal than the last defensive player. And that's pretty important because when you do the last pass, the goal can, for example, be denied, and they can say, okay, the ball went into the goal, but it was not according to the rules. So that's pretty important system. There was a lot of headache with that system during the Qatar World Cup because there was a lot of moments when that system was so precise that literally by centimeters it was denying the goals that in traditional football would be most likely a valid goals. So that system got me motivated. Okay, how can I, as a fan of the sport and computer vision engineer, how can I replicate that? Obviously, I don't have the funds of the FIFA, so I needed to scale my operation. So what we did is we basically created a very simplified environment when we basically had two cameras looking at the same object. Importantly, those cameras were located at some specific angle. So they are looking at the same player, but the lines between the player and the cameras are basically forming 90 degree angle. And that's because I wanted to simplify the post-processing stage. I will cover that stage later on. So originally, which I learned like after I done the project, FIFA used 18 high-resolution cameras to track all the players on the football field. Like I said, we scaled down the operation and we had only two cameras. And obviously, they use that camera to track multiple players. I will maybe talk about that a little bit later. So that's the setup. That's the physical setup that we've done. And we recorded the same person with two different cameras, but have the same resolution, the same frame rate, and like I said, 90-degree angle, looking at the same person. And the first kind of like the thing that we've needed to do is to synchronize the video. So if we want to, I wasn't processing that in real life. So I just recorded the data and came back to home and said, okay, we need to do something cool with it. So I had, static files, recordings, and I needed to synchronize that. So that was a bit manual process, but we managed to do that. And that was the input to the processing stage. So after we collected the data, there was like two stages that we've done, maybe three. The first process, the first part is feature extraction. So we run the models. I will just right away tell you a little bit about the model. The second stage was calibration of the data that we've managed to extract. And we will also talk about that. So how do we make sure that we match the location of the player in 3D space and that makes sense? And the third process is obviously visualization. I certainly spent too much time on visualization stage, but sorry, English is not my primary language, so that word is always causing me trouble. And let's go through those stages right now. So, like I said, the first one is feature extraction. So, like you see, we have two problems over here. The first one is extracting the skeleton of the player. from two videos at the same time. And we used pose estimation models to do that. There are plenty of pose estimation models. Lately, there is a control net that can be used for pose estimation. There are also models that are coming from the Tektron 2 library from Facebook. I, however, used YOLOv7. YOLO is not necessarily known from having pose estimation capabilities, but quite lately, like I guess since YOLOv6, all later version like V6, V7, V8 are adding more than just object detection. And YOLOv7 has segmentation detection and pose estimation. And so that's why I said, okay, let's use YOLOv7, because YOLOv7 had two components that I really wanted to have, which is pose estimation and object detection. So here we have a visualization when I show you the extracted features from those two models at the same time. It is a bit painful because YOLOv7 does not allow you to process the same video with two models at the same time. So you need to be creative with the DevOps shenanigans around the whole processing stage. But that's what we extracted. Yeah. So we extracted obviously the bounding box for the ball. And we extracted all those positions of all those joints that form the skeleton. It's also very important that I know exactly what joint we are talking about. So it's not like all dots are the same. It's like I know that it's, for example, left hip or right knee, or it's a left shoulder. So I always know what is what, and that simplifies the processing tremendously, because when I have two videos and I need to match position of every specific joint, it is doable because I know which one is which one. And that is the same for every pose estimation model. So whichever of those that I just said you would use, you would have that additional metadata about the joint so that you would know which one is which. So that's the feature extraction stage. Now we need to talk about the calibration. So I didn't really want to overcomplicate everything. And when we will discuss the next steps where I want to take that project next, I will need to overcomplicate things. But for now, I just wanted to keep things simple. So like I said, we recorded the object with two cameras at 90-degree angle. But what I didn't control is a focal length or the position of the object within the frame. So that was something that we didn't really put a lot of effort into making sure that both cameras have the same properties, because those were two different models of cameras, different focal length, different resolution, maximal resolution, plenty of settings that were not matching, and that caused me trouble, but also not necessarily. So that would be very problematic if I would have two objects that I want to track at the same time. If I had just the one object, I could simplify the whole processing, and that's what I did. So like I said, on both videos, I knew where is, for example, the left ankle, so I can match those locations. The problem that you see is that the person on the right image is kind of like proportionally significantly smaller than the one on the left image. Mm-hmm. And that causes you trouble when you want to match the coordinates, X, Y, Z coordinates coming from those two videos and construct the 3D model. So what we did is we cropped out information about the person. We can do that because we have, for example, metadata coming from object detection model. And we scale that model to some specific height, keeping the ratio at the same time. So what I did is I assumed that my player will be 1 meter 80 centimeters tall. I scaled all those points accordingly so that it would represent the person who is 180 centimeters tall. And that allowed me to simplify the matching process. So my assumption was, and that's why I decided to go for 90-degree angle between the camera views, is that the first camera will give me information about XZ plane, and the second camera will give me information about YZ plane. Yeah, and because cameras are at 90-degree angle, that's the easiest thing to do, because you get that out of the box. You don't need to do any triangulation. You need to do any advanced the math that would usually be required to calculate the positions of objects. So that's what we did. And because we made that one pivotal assumption, everything would be super simple at that stage. Importantly, it is not mandatory. You can have those cameras at any angle. Just make sure that the object and two cameras are not in the straight line, because if they would form the straight line, in reality, you would get the mirror image of the skeleton just from two cameras, and that wouldn't give you this additional information to form the 3D model. But
you're
because I have this,
so are two cameras required to do this?
At least two cameras are required to do this. Also, at the same time, it's worth to mention that there are some post-estimation models coming from Intel. I hope I can throw the names of the brands over here. Coming from Intel that is allowing you to have a post-estimation in 3D space. The problem is that it doesn't allow you to have the object detection in 3D space, and that ruins the whole idea of having the interaction. So what we did is we used two cameras to have the 2D planes from every camera, and we combined that information. And also what is, okay, I can answer that question right away. So in real time, I can process around 10 FPS, but I was using models that were for sure too large. So I would assume that I can go to like 15 FPS relatively easily by just using smaller weights of the model, because I was, for example, using large model for object detection. That was absolutely not needed. I would get away with like small. The scene is so simple, but that I would most likely get away with small model for object detection. I'm not super sure that I would get away with small models for pose estimation, but 15 FPS on Google Colab, which is also important because that's not like the most God-like GPU that you can think about, is absolutely doable. So coming to my answer. Two cameras were required because I was using that specific model. Most likely you would be able to get away with one camera, but then you wouldn't capture the interaction between the ball and the player. And like I said, what they did on FIFA World Cup is most likely exactly the same approach. So they used multiple cameras and used 2D pose estimation, just did a lot of clever math under the hood to reposition things according to focal length, distance of the camera. They done most likely a lot of clever stuff other than just modeling. So there's that. And because we've done all of that manipulation of the data, at the very end, we can create a visualization like this. And that allowed me, so this is basically the result of matching 2D positions and creating a 3D position for all the joints. That visualization actually created in Matplotlib, so I can tell you that even with that super simple library, you can create visualization like that. And this is side by side. So this is where we see how well can we match the position of the ball and the player in the 3D space. So so what was the most challenging part? I was just coming to that. So if you give me like a span of 2 slides, I will be able to answer that because I have kind of like the example. So there is that. That's basically the final output. I plan to scale that project, like I said, a bit. And now let's talk about what would be the scaling of that project. So first of all, I actually am not necessarily a big fan of football or soccer. basketball is my primary sport that I kind of like care about and watch and spend my time reading paper information about and stuff like that. So I want to move to basketball, but basketball is actually harder to do because cameras tends to be closer to the actual action that is happening on the court. And there happens a lot of occlusion is happening. So a lot of moments when one player is standing in between you and another player, and because of that we cannot accurately calculate the position of all the joints of that player because we simply don't see him. So the model would just basically pretend like it will produce some skeleton, just you have no guarantee that is a correct skeleton. So and that is a problem not only when we see occlusion. I had the problem when Chris, who is on the video, was doing tricks that required him to move super fast. So that video was recorded at 50 FPS in pretty good light conditions, and we still had a lot of problems like you see here, like blurred legs were very frequent. He's moving super fast and even 50 FPS with the equipment that we had was not enough to capture that in crisp quality. And because of that, once again, like with occlusion, model is guessing. Model is just kind of like pretending that it knows what is happening here when in reality it doesn't, and it's moves his knee, for example, a bit lower. But on the other side, it also kind of like here, what happened? I have no clue. Like why do we get that prediction? I have no idea. This is just one frame, but this is the biggest problem because we have minimum level of information. Like all I have is that free coordinates that I get from those two cameras. I don't have any extra redundant information that I could use to validate that position, for example. So because I only had one camera that could give me that particular location, and actually on both cameras it's off, when you see the visualization, there is a moment when he's doing that trick, and there is like something weird is happening. It will happen like in a few seconds. When we start the loop once again, you will see that it's a mix-up over here. It's like the visualization shows you that there is one frame that is completely off, and for that reason, the whole effect is also completely off. It happens for just a split of a second, but because we have those traces that comes from the ball trajectory and from both foot trajectories, we can see that it's not a clean movement. Like here is very clean movement. We don't have any occlusion. We don't have any misdetection. But here, during that trick, it happens, and it kind of like ruins the effect that I was aiming for. So certainly, false detections are key problem over here because it's very hard to get the nice result, the smooth animation when there can be one or two frames that are just missed for all those reasons that I mentioned, or like we see over here, for no reason apparently it just happened. And we don't have extra data that we could use double check that position. So what I plan to do is expand the operation. I want to have more visual data. The plan is to have either 3 or 4 cameras that would look at the same position. That should unlock that use case where there is like one player leaning on the other during the post-up. In basketball, it happens a lot. And in that situation, you have good visibility from both sides, but you don't have a good visibility from the front. But you also have visibility from the back. So if I would use 3 cameras, I would be able most likely to use some advanced matching, advanced post-processing, and capture a position like here is LeBron James, the position of his hands, for example. I would be very problematic with my approach. Most likely I wouldn't get any real result that would make sense. Yeah. And I want to strive for that result. So that's what I most likely will use. And that's the plan for the next steps. And I also I don't stop at pose estimation. I do a lot of other things where I use computer vision in sports. So this is just another project that I did. It tracks players on the football field. It tracks the ball, and it tries to assess which player is currently in control of the ball. But it also kind of like can distinguish between referees, so that's also pretty important. So I try to use computer vision in all possible scenarios. I actually am going to use computer vision quite soon. Spoiler alert: there will be most likely video relatively soon where I will use computer vision to assess. In basketball, there is something called 3-second violation. That means that the player cannot be close to the hoop in some specific area for longer than 3 seconds. And if that happens, that's a violation. That's kind of like the turnover. And we want to automate that process. So we will set the zone and we will track all the players, and we will say whenever the player is in that specific zone for longer than 3 seconds, we will let you know. So we try to apply the computer vision in all possible scenarios. So there's that. And if you want to learn more, you can scan the code. It will redirect you to my GitHub page when I have like a ton of similar projects that you can take a look, maybe get inspired. Yeah, that's it. 26 minutes. I hope it's still okay. You are muted, so. Still muted.
Sorry about that.
No worries.
All I was saying is that I was super interested in this the whole time, and that there was a number of questions. And here's going back to Kate's question.
Okay, so the most challenging part, like I said, it is basically handling misdetections, handling that because with only 2 cameras, I literally don't have anything to lean on to assess the detection, because Chris is moving so fast that any form of estimation that this amount of movement between 2 frames is invalid, it doesn't work, because he's moving very, very fast. He can bounce the ball up and move his feet 3 times around the ball before the ball is going down. So he's really moving super fast. And for those reasons, I cannot validate the position based on pure math or its impossible movement. I would need to have additional information to cross-check that, and I don't have that information. So handling that is super important. There may be a reason for me to look at other models because of that, because other models like YOLOv7 is giving you the possibility to do pose estimation, but it's not well known for pose estimation. It just have that capability. And there are state-of-the-art models for pose estimation, slower. That comes down to the previous question, like how many FPS I can get, because I wanted to be relatively fast, close to the real time. 15 FPS is okay-ish. It's not perfect, but I could process every other frame and maybe get away with that. But with larger model, I would burn more time for prediction, and obviously that would influence the performance. So yeah, that's clearly the biggest problem that I had, and I assume that would be the biggest problem in the next stage. So occlusions and handling that, but that's not my problem, at least for now. So.
All right. Do you have thoughts on where someone can get more information?
About this particular project, or generally speaking about pose estimation in sport? Because if you want to learn about this project, I actually open source the code for that, so you can run the whole script, both stages, feature extraction and second stage post processing and visualization. You can run both of those scripts on your own. If you the only thing that you need to have, and I know that other people use that already. I know that some people use that for weightlifting. So there are people who use that particular script to model the movement of the person who is lifting weights. And they also used exactly the same setup, two cameras, 90 degrees angle. So if you follow the QR code that I showed at the end, I can maybe give you a link to my GitHub repository in the chat right now. That could also help you out. If you want to learn more about the kind of like the whole idea of 3D pose estimation, then, like I said, good place if you just want to use a single model. I'm just pasting that in the chat. I hope it's visible on LinkedIn. I'm not really sure, but if everything works, then it should be. So that's the link to the repo where you will find that particular project and, like I said, the code. But Intel is doing quite a lot of movement in the direction of using like straight away like 3D pose estimation based on just a single camera. So if you will type in Google like 3D pose estimation Intel, most likely it will give you some results.
All right, and then Kate's back again. But yeah, I've sort of had a similar question too. Like, obviously, YOLOv7 does object detection and pose estimation. Like, do you know sort of what the offering is of the different versions of YOLO?
I try to keep track of kind of like what is the offer of every of them, which is not super easy, and it requires a lot of time and research to know what is happening in each of those projects, because the name doesn't really give out the information that V6, V7, and V8 are. All of three of those are actually live projects, and the fact that there is V8 doesn't necessarily that V6 is out of date. They're actually built by three teams at the same time. The V6 is coming from the team from China. I'm not necessarily sure which company is kind of like overseeing that process, but V6 is coming from China. V7 is coming from the original creators of YOLO. So there is the guy who was originally in the first YOLO papers, and there is YOLO V8, which is done by Ultralytics, the team behind YOLO V5. So all of them have different offers. Pose estimation is unique because none of other three have pose estimation. Object detection and segmentation on YOLO V7, classification, segmentation, object detection, and tracking lately are YOLO V8. And YOLO V6, I guess, stayed with object detection and segmentation, but I might be wrong. So if that's not correct, please don't hate on me. I try to be up to date, but it's all moving so fast that's pretty hard. And obviously, if we talk like about V7, like all object detection use cases that comes to your mind, obviously, because it supports that natively. That's pretty straightforward move. Segmentation, like very, very useful if you want to use in robotics, because you get the real-time processing almost. Segmentation in YOLOv7 is very fast. So if you have moving robots that just need to have a better precision than object detection gives you, because the bounding box can be a little bit annoying, because it gives you a lot of wiggle room when object doesn't necessarily need to be there, but from bounding box it looks like it's there. Segmentation is much better. So robotics is very often the use case for that. And obviously pose estimation. So for pose estimation, we actually had, because that project kind of like went very viral on Reddit, and I get like a ton of comments, and people were proposing what else can you do with 3D pose estimation. the two coolest ideas is like you can use that to capture the movement of actors when you do a video game. So there is kind of like the movement capture process that when people just play, and then the movement of the actors is mimicked by the game characters, and you can actually use this approach instead of the traditional way, which is super, super, super expensive. So if I would have enough money, I would have like so many redundant data that it would most likely work relatively fine. And martial arts, I guess that was also a pretty cool concept, because in boxing, you give each player a point when the hook or whatever punches he's throwing is actually touching the other player in relevant places. Yeah. And it's pretty hard to do it without pose estimation. But with pose estimation, especially 3D pose estimation, a part of the position of the hand during the punch, you can also capture the velocity of the punch, and based on that, you can actually assess whether or not it was a punch that was on target or not. Because if the velocity is drastically coming from some high value into zero, for example, that means that you most likely hit somebody, and you can, for example, do a automated scoring of box matches, for example. So those are just kind of like the ideas that comes like from the top of my mind from that Reddit thread, but it's pretty easy to come up with other scenarios when that would be useful technology. Does YOLOv7 has only face key points extraction, or do you have to use full pose estimation? I'm not really sure if they have face key points. Detectron 2 for sure have face key points. Google has also like a library for face key points that is actually currently used on Kaggle, because there is a Kaggle competition that is about sign language, and they have information about the position of every joint on the hand, and also about like, I don't know, like 3,000 points on the face. So I wouldn't use YOLOv7 for face key points. There are certainly better tools for that. The cool thing is that the YOLOv7 approach is it is not purely scoped for pose estimation for people. You can do any pose estimation. So if you would like to train the model to have a sign language and have every joint on your hand as a joint and have like, I don't know, like 15 joints modeled, you can do that. If you want to have a pose estimation for your dog, you can do that. So YOLOv7 gives you the ability to train your model on custom data that is not necessarily person, gives you a flexibility. So that's an upside for sure.
So I have a silly question. Do you think this will help to like that we won't need referees someday?
For some tasks, I feel that we are already reaching that place. So VAR, because VAR, sorry. So because that's the technology that I was talking about at the very beginning. It worked like, I don't know why did we even need a referee on the football pitch for that, because I was watching that World Cup, and there was never a situation that the referee overthrow that. Sorry, I'm not really sure. Overthrow that verdict. It was like purely dictated on the automated output, and referee was there only to confirm that we are, treating that output as a valid decision. So I would say most cases, not necessarily, because it's still very hard to assess whether or not there was a foul, for example. You need to have the additional component of the person being there, listening to conversation in the meantime, because it also matters. So there's that. But for offsides in football, in my opinion, it's already kind of like solved problem, and it will be fully automated.
Wow. Another, this might be a silly question. So obviously in the slide that we're looking at, that person was detected. we have our pose estimation on top. Now, previously you had the ball, and the ball was being tracked, and it was a red circle, and there was a line around it following it. What was that pose estimation, or is that tracking? What was that?
Okay, so I know what you're talking about. Okay, so if we let me just you mean the kind of like the track that is traveling around after behind the ball. So what is that is actually I created a mechanism that remember position of the ball always like 20-25 frames back. And because I know where the ball was more than a second ago, I can recreate the whole trajectory of the ball in 3D space. Yeah. So it looks like you would draw with the pen or something like that, but it's actually what this is actually is that it gives you a window that allows you to look into the history where the ball was a second ago. And because I do 3D, I can do all sorts of things. I can rotate that trajectory and create this illusion that is basically like suspended in the air, but it's just a history of the movement.
Yeah. No. Okay. So that was custom. Perfect.
Yeah, custom based on the analytics and the fact that I have the history that I can use. Yeah.
Okay. And so, and the algorithm requires a minimum of 2 cameras to do this, or could you do it with 1 camera and get like a crappy estimation?
So this is what you get from a straightaway single camera with YOLOv7. You get 2D pose estimation. Yeah. So in some specific use cases, it might be just enough for you, because if you control the scene very strictly, you can enforce a situation where that's just enough. I saw, for example, when people used 2D pose estimation to control characters in like 2D games, like, I don't know, like Mario, for example. So they are there standing and they, for example, jump. It is just enough for me to assess whether or not the person is jumping or it's crouching or it's punching, because if you stand, sideways to the camera and do the punch, I can build an algorithm based on position of those joints to control a game, for example. And I saw that happening. So coming back to your question, like, no, you will not get crappy estimation. What you get is 2D. But still, if you control the scene and know what is happening and put enough constraints on the person on the scene, you can create a really advanced like functionalities with just a 2D pose estimation.
But do you have to think about how you're moving? So when you're saying like considerations around that, do I need to?
So for example, being sideways, if you want to detect the punch so that it would be reflected in the punch in like I don't know, like Mario could Mario punch? I'm not really sure. But if Mario could punch, for me to detect that that's your intention for him to punch, it would be significantly easier if you would be standing sideways and punching like that than standing straight up and punching like that. Because if you think about the position of those joints on the 2D space, that movement, if you go straight into the camera, that point is not moving,
right,
on the 2D space. So how can you assess that? But when you are like that, you see clear movement, and that's actually pretty easy to just hard code the rules. Like if the hand is moving forward and the rest of the body is standing still, that most likely means that you're throwing a punch. So you need to think like those are the constraints that I was talking about.
Yeah, and so you have these 2 videos and the guy was smaller in one. Did you just say like make this whole video X amount larger and then the algorithm knows how to sort of
So like I said, let me just zip water a bit because I'm talking a lot. So like I said, I didn't really want it to overcomplicate, because that stage of the project was just kind of like me probing. Is that possible? Because I want to do things that will be significantly more complicated later on. But I didn't want to just jump into like very ambitious problems at the very beginning and just, abandon the whole project altogether. So what I did is exactly what you said. I capture the bounding box coming from object detection because you see the problem is that those joints are not like the position of the bottom joint, like the lowest joint on the skeleton, is not the position of the feet. It is actually the position of the ankle. So I needed to correct for that, and I actually used, and it's exactly the same with the head. The highest point that I get is the ears, or the or the eyes, depends on the position relative to camera. But I need to have the top of the head. So that's why my object detection that is displayed over here is very handy because I can do that. Yeah. So what I did is I actually kind of like manually calculated like if the guy would be. So I used the frame when Krzysztof was standing, and I was like, okay, he's 190, 180, let's say. So if he's so 180 is exactly this amount of pixel, and on other is exactly this amount of pixel. And I use this kind of like heuristic to scale up the crop, but like I said, keeping the ratio of the crop at the same time. So I not only kind of like scale him up, I scale him in both directions, because if I wouldn't do that, he would be like paper thin in one dimension, and that will be visible on the visualization later on.
But so is that like dynamic? If that guy runs towards us and gets bigger,
yes, that is dynamic. I have that handled. But at the same time, I know that this approach I can only get away with that approach if I have one person on the scene. When I have two people on the scene, not only I will need to come up with the algorithm to match them and know which skeleton on the left side is which skeleton on the right side, I will also need to have a more clever approach on matching those boxes and scaling information. So that's why I say I will be much more strict about focal length and the position of the cameras, because right now I didn't use any information other than just an angle between the cameras and the person. In the next stage, I will use information about the distance from the camera also, because I will use more advanced math to just calculate those things, instead of just assuming that it's what is happening, because on the real court, those assumptions will most likely not help. Yeah, and I would need to be able to calculate those things in scenarios that are hard to constrain with those restrictions.
Is that what you're working on now? Is 3D pose estimation with more than one person?
Yeah, because I already submitted that I will be part of the conference in Prague in a few months. I plan to have like extended project. Yes, so I'm not necessarily code anything yet, but I have the planning. I need to have a place. I need to have players. I need to have enough cameras. I need to do all the kind of like physical equipment stuff, so that when we actually record, I wouldn't need to ask all of those people, oh, okay, guys, we need to meet one more time because I screwed up some assumptions and I won't be able to deliver. Yeah. So there is a little bit of thinking and planning. Yeah.
Wait, so you've submitted a talk and you haven't built it yet?
I can always say that, here's what it is, guys, take a look. Yeah. And maybe it won't be the worst talk. I have no clue what people will show, but maybe it will not be the worst talk. But
I just love it so much.
No, the extra swagger will definitely come with multiple players on the field. Yeah.
Extra swagger. Awesome. Okay, is there anything that you didn't share here that you'd like people to know?
No, I guess we covered everything. I got grilled with all of those questions, so I guess we covered everything.
Well, yeah, I mean, because that's what I want to play with pose estimation next. So
I know. From our private messages, I already know. I connected the dots. Okay, you can always hit me up with the questions after the conversation. I'm still going to answer. No worries there.
Yeah. No, that's when I ask the silly questions, though. It's like,
nothing is silly. I mean, like, pose estimation is actually like, it seems that it's, getting there when it comes to be well known and maybe kind of like people are aware of that. But I was doing the research to choose the algorithm when I started that project, and it's not easy to even pick the model that you use. It's like
Mm-hmm.
okay, there are more accurate models, but I tested them, and at some specific angles, I got such a crazy result that it was basically unusable. So, it depends. And I just remember the name of the Google library for phased key points is MediaPipe. So MediaPipe on GitHub, and that library is pretty good when you talk about phase movement. So just uh, it, unlocks something in my head in the meantime, and I remember.
Awesome. Awesome. Well, thank you so much for coming on today. This project was fascinating. I absolutely enjoyed
My
watching
pleasure.
and listening to the whole thing. I thought this was great. Um, if people want to get in touch with you, I know you already shared your QR code. Do you want to?
I can share it one more time, but
Yeah. Or, yeah.
you can just scan it and it will redirect you to my GitHub account, where you will learn everything about my Medium and my LinkedIn, my YouTube, and all other stuff. I don't know. I'm not really sure if there are any links that you shared in the description of the event.
Or are you most active on LinkedIn or
I'm most
Twitter?
likely active on LinkedIn and on GitHub, yeah, because naturally I try to code as much as possible. But when it comes to talking and sharing something, it's you will be definitely up to date with my LinkedIn account, so that should be fine.
All righty, awesome. Well, so thank you so much for joining us a second time, and I hope everyone who's watching has an amazing day, and I look forward to seeing you guys soon.
Exactly. Have a nice rest of the week, and I hope to push the record further and be here for the third time at some point. I'm not
Number three.
pushing, but I still maybe will figure out some cool project to show. Yeah. Okay.
Yeah, no, if you figure out the thing that you're going to share at that conference, call me.
Okay. So now we know more or less it will be somewhere in June. Okay.
Awesome. Have a great day, guys.
Yeah. See you. Bye bye.